So I'm Andy Davis, Research Director of NCC Group, and we're going to be talking today about USB and more specifically how to extend USB attacks which traditionally have been local physical access attacks over a network. As you might see, I've got quite an array of equipment here, so I'm hoping to do a number of live demos. I hope I haven't kind of overstretched myself here. I could have taken videos of the demos, but hey, that'd be cheating. So hopefully, fingers crossed, all the demos are going to work. But it involves kind of like moving cameras around and me putting the microphone up and down. So we'll see how it goes, but stick with it; it'll work. Okay, so first of all, we're going to talk about what the main problem with USB bugs is. And when I say problem, this is kind of the main reaction I get from people when I demonstrate USB bugs. Then move on to talk about how I go about identifying USB bugs. I've been looking at them for a number of years, come up with a range of different approaches for finding bugs. So I'll go through some of those, talk about some of my experiences, some of the things that I've found. Then demo an iOS 7 bug that was patched, and the patch was released the other day. We'll then talk about kind of the first stage of me trying to move away from physical access with USB. I came up with this kind of concept using Bluetooth. It's a bit of a contrived example, but you'll kind of see why I went in that direction, and then we'll do another demo. And then finally, we'll talk about the kind of full-on remoting of USB attacks, hopefully do a demo that works perfectly, talk about what the implications are, and then what you can do to prevent people mounting these kind of attacks. So the problem with USB bugs. Obviously, traditionally, physical access is required. I've found and reported many USB bugs over the years, and the normal response that you get from vendors is, yeah, well, you know, you need physical access, you need to be able to get to the box and plug something in. Big deal, it's going to have code execution implications, but you know, if you've got physical access to the box, you can do what you like, right? So vendors, some of them aren't really interested at all. Others kind of understand what you're trying to get at. And local bugs certainly have their place. And I think the thing that people don't tend to realize is how, yes, you need physical access, but how little time you need to actually perform something malicious using a USB device. So the majority of the bugs that I've found have been associated with the enumeration phase. So when you plug in any USB device, the host that you're connected to doesn't know anything about that device, and it has to go through this phase called enumeration, where it's a kind of a question and answer session between the host and the device to try and find out what type of device class it is. You know, is it a mass storage device? Is it a printer? Is it a camera? That kind of thing. Then, you know, what speed does it want to run at? What kind of capabilities does it have? And also, what kind of protocols does it want to talk once the driver has been loaded by the host OS? And during that whole phase of communication, there's a hell of a lot of data that's exchanged between the host and the device, and the device and the host. And therefore, it's quite easy to, once you have developed the kind of fundamental capability of providing USB data from a rogue device back to a host, there's lots of areas where you can provide malformed data that triggers crashes, software flaws, many of which are exploitable. So that, as I'm sure you're all aware, having used USB devices, that enumeration phase is a matter of seconds. From the point of plugging in the device up to when it's working is only a few seconds. And it's during that period of time that if you triggered a software flaw in the parsing of that data, which was exploitable to execute arbitrary code, you could then execute code purely by inserting the device. So that's the kind of story that I tell to the vendors. Some of them get it, some of them don't. But it's been a long battle. So here are a few of the examples of bugs that I've found over the last few years. Going back to 2011, one in Sun Solaris. All of these, by the way, would result in potential code execution by the attacker. And I've got to point out that my kind of field of expertise is finding bugs, not actually writing the exploits to exploit these bugs. So, I'd spend my time writing fuzzers, generating crash test cases for people to then go off and triage and write the exploit code. So I'm no kind of, certainly when it comes to kernel level stuff, I'm, not really an exploit writer. Having said that, if I provide these crash dump details from my fuzzer to the vendor, and the vendor comes back and says, yep, code execution was possible, then somebody could potentially write code, malicious code, in a USB device to exploit some of these conditions. So as you can see, they're all pretty modern operating systems. That Sun Solaris one was on Solaris 11. So I think the reason that we're still finding USB bugs is it's a relatively new field. As you'll see in the next couple of slides, it's not something that you can do purely with software. You need a hardware component in order to test a USB host. It's very different if you're testing a USB device like a phone or a camera or a printer, that kind of thing. You can do that purely from software. But in order to pretend to be a USB device and plug into a host like a server or a laptop, that kind of thing, you need a hardware component. So back in 2011, I had my first attempt at creating some hardware to emulate USB devices and used an Arduino microcontroller. So the fuzzer that I wrote was very basic in C++ for controlling this microcontroller. Because the microcontroller wasn't particularly powerful, wasn't particularly fast, I was only able to emulate USB low-speed devices like HID devices, so human interface devices, things like mice, keyboards, that kind of thing. And it only allowed for kind of semi-automated fuzzing. Having said that, it did find some pretty high-profile bugs, and it kind of justified to me and to my management that provided me with the funds that I could continue doing some research in this area and buy some more equipment. So I needed to move on from this and buy something a bit more powerful to allow me to fuzz faster devices. So in 2012, I identified a piece of test equipment which it doesn't look like much. It looks like it's a piece of kit that you buy from Radio Shack, but it's actually a pretty powerful box, and it's produced by a company in the UK. And what it essentially allows you to do is capture in a kind of a proxy type fashion USB device between USB data between a device and a host. So it's kind of like Wireshark for USB in a hardware device. But the beauty of it was once you've captured all these packets associated with the interaction of a USB device and a host, it's got its own built-in scripting language that would allow you to replicate and replay that session that you just captured, which is great from a fuzzing perspective because I was then able to modify that data and write a fuzzer based around this particular bit of test kit. Unfortunately, the scripting language itself wasn't powerful enough to write the fuzzer in, and unfortunately, there was no software API to control the test equipment. So what I ended up having to do was inject Windows events into the GUI software, Windows GUI software that came with it, using Python and wrapping Python around it and spawning it and modifying the generator file script every time and getting it to replay it. So it was a bit of an ugly hack, but it certainly worked, and it found a huge amount of other USB bugs. Now I had the capability to fuzz faster hosts, or emulate faster devices, rather. But of course, along with those limitations that I've talked about, another limitation was you actually had to have an example of each of the devices that you wanted to play. It's literally a mutation-based fuzzer. So you have the device, you plug it in, you record a session, and then you kind of mutate it based on what you want to fuzz. So the latest iteration of fuzzing is using a board called a face dancer board. This was developed by Travis Goodspeed in the US. And essentially what it allows you to do is emulate USB devices in Python. So as long as you understand the details of the different protocols associated with the different device classes, using Python code, you can virtualize any different USB device class and send data associated with it. So no longer do you need to do the kind of mutation-based fuzzing having captured from a real device. You can just spawn up a virtualized USB device of your choice and mutate the data as you like during the enumeration phase or during the class-specific phase. So after enumeration and the host understands what the device is, it understands what language it can talk to that device. So then you're talking about class-specific communication, and I've found bugs in that as well. So it's a pretty powerful way of doing it. And the tool that I wrote, UMAP, which controls face dancer, is available on GitHub. I released it at Black Hat USA last year, and it's something that will develop over time. At the moment, it's got a reasonable list of kind of base classes, device classes, that allows you to kind of pretend to be those different devices. And based on my kind of expertise over the years of what types of mutations within the enumeration phase and the class-specific phase trigger bugs, I've created a whole bunch of test cases that then apply to these different protocols. So that's all there, and you can download that and use that. So most recently, and the advisory for this went out last week, UMAP identified arbitrary code execution in iOS 7. So it's pretty powerful stuff. I mean, if somebody actually wrote an exploit to exploit this particular vulnerability, we're talking about tethered jailbreak here. So the fact that these kind of things are still there and they can be found with open source tools, download UMAP and have a play with it. You never know what you might find. My iPad I've got here is still running an older version of iOS. So basically any version of iOS prior to 7.1 is vulnerable to this bug. So I'll do a quick demo showing you how to use UMAP and also hopefully triggering the bug on an iPad. Now, because my resolution was forced to 1024 by 768, everything's going to be a bit squashed on the screen. So what I've got is, where's my face dancer board, and that's connected. One end of that is connected into my laptop here. The other end is connected into, let me just bring up this camera, into there. So you can see that's USB connected into there. And let's just point that at the screen there. Okay. So first thing to show you with UMAP, if you do UMAP minus L, it's a bit difficult to see with the, okay. Well, you get the idea. So basically what it's showing you here is all the different device classes that it supports. So within USB, the class information is specified by 3 different bytes. So you've got the base class, the subclass, and then the protocol that's used. So each line on here is a different type of device. So if we take this one, for example, so the base class for printer is 7, subclass is 1, which is the default, and the protocol is bidirectional interface. So you can specify that you want to emulate one of these devices and virtually plug it into the iPad. So the first thing that I'll demo actually is if you just do a -i, it will iterate through all those different device classes that the UMAP supports and just try them. So it will see whether the host that you're connected to actually understands that device. So if I do a -I, and actually if we keep an eye on the screen there, fingers crossed. Right, okay. As you can see, it's not super fast. It goes through each one, maybe takes about 7 to 10 seconds per device that it's emulating. It's going through the whole enumeration phase. Now there you can see messages coming up on the iPad. So, cannot use this device, doesn't understand this USB device, device not supported. So when it does eventually find one that is supported, which hopefully will be very soon, there we go. So you can see it understands HID devices, it understands image devices. In fact, when it thought we'd plugged in an image device, it tried to display the photos on that image device within the iPad. So it's kind of like mmap for USB, hence the name UMAP in this sense, from a kind of a discovery perspective. So it's identifying which of these protocols are supported before we actually go ahead and do any fuzzing. Nearly done. This is the last one. So we can see there that it supports HID devices, keyboards, mice, that kind of thing, image devices, so cameras, and mass storage devices, so USB sticks, memory sticks, that kind of thing. Now, the particular bug that, that I discovered in iOS 7 was actually in class-specific information and applied to my storage device. So what I'll do, I think I've probably still got it in. If I do, I'll just type it in. Okay, so you can do like a -F option, which will go through and fuzz through all the different test cases within the test case file, but I know a specific one that triggers this bug. So if I choose the device class of mass storage device, so 080650. Actually, this is in the enumeration phase, not class specific. Enumeration phase, and I know that it's test case 45. So if I move that across, you can keep an eye on the video screen there. So if I now send this, fingers crossed, let me just double check. That. Okay, so it's sending that test case, and oh, there we go, kernel panic. So that's just rebooted the iPad. In a minute you'll see the Apple symbol, so it's restarting there. Now, as demos go, it's not particularly exciting, but at the end of the day, it's showing the fact that purely by sending a rogue communication via USB to the iPad via USB, it causes a kernel panic and reboots the device. And as I said, Apple confirmed that this is actually an exploitable vulnerability that would result in arbitrary code execution in the kernel. So, moving on. So, excuse me. So that's just an example of UMAP and how I find USB bugs. So the next thing was, okay, how can I move away from it being some kind of physical access? I want to be able to do this stuff remotely. And back in 2011, I discovered a bug in all versions of Windows in hidpars.sys. So when you plug in a HID device, a keyboard, for example, as part of that communication that happens in the enumeration phase, a thing called a HID report descriptor is sent, which basically talks about the capabilities of that HID device. What kind of keyboard it is, how the keys are mapped on that device, what language keyboard it is, all kinds of stuff like that. And identified, if you specified a certain value within a certain field in a HID report descriptor, it created a logic error that resulted in a null pointer dereference. Now, I sent this to Microsoft and they weren't particularly interested, and fair enough. I could plug in a device which will blue screen any Windows box, but it's a null pointer dereference. So it's not particularly exciting. It's not exploitable. I can't execute any code. I can just blue screen the box. You might as well just power the machine off if you've got physical access to it. However, oh yeah, and there's just a screenshot of a blue screen showing that hidpars.sys triggers, and it's still every version of Windows is vulnerable to this. So I was thinking, what else uses HID report descriptors? Well, Bluetooth keyboards do, and I thought, well, surely Microsoft wouldn't have a separate HID parsing routine for Bluetooth keyboards and for USB. So maybe this bug that I found that was in USB would also be valid for Bluetooth. Because the report descriptor has to be parsed in exactly the same way as when you plug in a USB keyboard. So, I know this isn't USB, and this was kind of like, I'm describing my thought process to try and move to a remote scenario here. So I'm just going to give you an example of this thing that I did next. Oh yeah, and as a complete aside, I demonstrated some of the USB bugs to one of my clients, and they were interested to know, could I just produce a little simple device that I could keep in my pocket and plug in to trigger some of these bugs? And I hadn't a spare Arduino, and various of the bugs that I created, I just hard-coded into the Arduino, so I could just kind of wander up and plug this device in. I would have brought it with me, but I'm a bit nervous about taking it through airports. People might think it does something else, especially in the US. So, okay, let's go for a Bluetooth demo. So what I've got here, let's get the video screen back up. Okay. Okay, so let me just log into this. Okay, so what we've got here is Microsoft Surface tablet running Windows 8.1, latest version, totally patched up. And what I've got here is a laptop running Ubuntu, where I am going to emulate a Bluetooth keyboard. And there's a nice little tool called HID Client that was written by somebody else, not me. And within there, you can specify all the details within the report descriptor. So, of course, I modified that report descriptor to be the malicious one that triggered the bug over USB. So, if I run the HID client, so that's now pretending to be a Bluetooth keyboard, and now move over to my Surface tablet and click Add a Bluetooth device. good. Took a little while. Okay, so there's the keyboard. This is my emulated keyboard. And I say I want to pair with that. Okay, does the passcode match? Yes. Does the passcode match? Yes. Okay. Ooh, what's happened? It's blue screened. Now, I know what you're all thinking. I had to pair with it. So, I had to type in the code on each machine, which is why it's a contrived example. But it kind of goes to show where I was going with this. And the next thing I thought was, okay, can you send it the legitimate report descriptor the first time when you pair, and then once you're paired with it, can you swap it for the malicious report descriptor, so next time you use the keyboard it blue screens? Unfortunately it doesn't. So that was kind of back to square one, but I've managed to move slightly away from physical access. So I just need to reboot this for the next demo. Nearly there. Okay, I'll leave that to reboot. Okay. Right. So I can see you're all totally blown away by that fantastic demo. It does get better, honest. Okay, so then I thought, how are we going to get this USB remoted? There must be a way of doing it. And then I thought, well, RDP is the kind of way that everybody remotes into Windows machines these days. And I remember that, there was lots of different things, lots of different devices and capabilities that you could remote from the client to a server when you connected via RDP. And these are known as high-level redirection capabilities. It's the kind of legacy capabilities of RDP that have been developed over the years. And they've kind of grown organically. It's almost like Microsoft have kind of added the ability to remote your printer, and then a user has said, oh, wouldn't it be great if we could, remote our local drives or remote our smart cards, that kind of thing. So Microsoft came up with all these different mechanisms for remoting things over RDP. Unfortunately, when you try and remote a USB bug, it doesn't quite work out. So what happens? Let's say, for example, you've got that particular example with the keyboard doesn't work. You can't really remote a keyboard over RDP, but I just happened to find another bug within a USB audio device. And USB audio remoting is one of those legacy capabilities. So I thought, well, easy. All I do is I'd set up my RDP client to remote the USB audio, connect up, trigger the bug, and it should work. But unfortunately, this is what happens. So you plug in your rogue device when your RDP session is set up, and you blow yourself up. And that's because the way it works with high-level redirection is it's using the USB driver on the local machine rather than on the server. Now, theoretically, if you used an RDP client that was non-Windows based, and you used something that I'm going to talk about next, there is another way around this from the way that I'm going to describe to you, but it's essentially using the same kind of thing. But basically, with high-level USB redirection, the kind of conventional way of doing things, you're only ever going to blow up something locally. Nothing gets sent to the remote machine. It's not the remote driver, USB driver on the machine that's parsing the data that's being provided when you insert the device into your client. And then, recently, or relatively recently in computing terms, last few years, Remote FX USB redirection was added. And I thought, wow, this sounds a bit interesting. What's the difference between Remote FX USB redirection and high-level redirection? Well, Remote FX is used for all kinds of things. It's not just USB. The USB redirection almost seems to be like a side story. Remote FX is primarily for kind of improving graphics capabilities over RDP sessions, doing funky things like that. But yeah, there's certainly an element to it which allows you much more control around USB redirection. So I thought, let's have a look at this. And fundamentally, this is taken from one of the Microsoft MSDN websites that talks about the differences between the high-level stuff and the remote effects. But fundamentally, it's the device driver on the server that's processing the data. Now, you've got to make sure that the bug that you're trying to trigger is in one of the standard device drivers that's going to already be on the server. Otherwise, you're not going to get anywhere. So, it's going to have to be a standard driver. But fortunately, the one that I'd found was in one of the Microsoft standard drivers. So as you can see, there's a whole bunch of different differences between USB high-level redirection and the remote FX stuff. Now, in order to use it, if you install RDP on Windows Server 2012, the remote FX stuff is just there. But from a client perspective, you need to do a bit of tweaking with your RDP client in order to leverage this functionality. So within group policy settings, you need to allow RDP redirection of the supported remote FX USB devices for this computer, from this computer, and then you do a GP update /force. So that will then tell your RDP client that you're going to be using remote FX when you connect. You have to reboot your client in order for that to take effect. And then when you go to your configuration for your client, within local resources and more, you've now got the ability, or you've got a new checkbox, which is other supported remote FX USB devices, and any devices that are currently plugged into your client will show up there, and you can add a tick box and say, I want to remote that device. In fact, within the kind of more granular RDP client configuration, you can specify any USB device by its GUID and say, I want to remote this device. So it's not based on specific use case types as it was with high-level redirection. Now it's much more generic, and the functionality is there to allow you to remote any USB device using remote FX. So now, theoretically, this is what happens, actually more than theoretically, because hopefully it'll work in a minute. So you've got your RDP client and your RDP server. Now, one thing that you need to do that took me ages to work out, because I kept on having the same scenario as I had before with the high-level stuff where I kept blue screening my client, is you have to emulate a normal non-rogue device first, because what you need to do is kind of capture the session within remote FX and tell the RDP server that a valid device of the class that you're going to send a rogue example of in a minute is to be used within that RDP session. So you start off by emulating the normal device, not the rogue device, within your RDP session. So the audio device that gets emulated by UMAP comes up as a creative headset. So you then tick that and say, yep, that's the one I want to use. You then remove that virtually, and you virtually insert your rogue device. And this time, the RDP server goes boom. Okay, let's see if we can get it to work. Okay, so what I've got is this laptop here is connected via USB to the face dancer board. The face dancer board is then connected to this laptop here, which has a remote desktop client configured on it. This laptop here is connected via a crossover cable to this laptop here. This laptop here is running Windows Server 2012, and that's what we're going to RDP into. So, the first thing that we need to do is RDP into the server. And what I'm going to do is, because you need to authenticate with it, I'm demonstrating that you can authenticate as the absolute lowest privileged user. So I'm going to RDP into the server as the guest user. So absolute lowest privilege. And then what I'm going to do from here is I will use UMAP to say I just want to emulate an audio device in its conventional sense. So it's not going to do anything, it's not going to send any malicious data, it's just going to emulate it. And then within the client, I'll capture that session and tick that tick box. Okay, and I'll put the microphone down while I do it so that I get it done without it timing out. Okay, epic fail. I just need to revert to snapshot on my Windows server. Snapshot. Which will take a few seconds. Okay, let's try that again. Yeah, it's worked. Right. Okay, so it's currently logging in. So that's now RDP'd into the Windows 2012 server there. Okay. Now, the next thing I need to do is grab the session associated with the audio device. Which I've now done. Okay, so there's the 2012 server, and I've now grabbed the audio device session for USB between the client and the server. So now, if I send the malicious data, which remember is connecting via the face dancer board to the client, it's only Ethernet that's connecting the client to this server that you can see up on the screen. I can do C4. Yes. Okay. So this has some pretty serious implications. It means that even if you've just got null pointer dereference bugs, if you can use those to remotely blue screen a server on the other side of the world, that changes the whole ballgame with USB attacks. What Microsoft have done with Windows RDP is they've exposed elements of the kernel over RDP, which allow you to do that, which is it's a pretty dangerous thing, really. And of course, this may also apply to other non-Windows remoting technologies. I've only looked at RDP in detail. There's a bunch of other technologies out there that this might potentially affect. So how can you reduce the risks? You can actually turn the remote effects functionality associated with USB redirection off. So if you're not going to use it, or you're scared about what you've just seen, I'd suggest turning it off. If you do actually need it, there is quite granular control that you can use to make sure that only the devices that you want to be used can be remoted via RDP. So, you know, make sure that it's configured correctly if you do want to use USB redirection via remote effects. But again, you know, you can disable it on the clients, or rather not enable it on the clients, because it's not there by default on RDP clients. I'd also suggest minimizing the use of the high-level remoting stuff as well. I think a lot of people don't realize how much remoting capability there is within RDP. And certainly be more cautious about local, or in quotes, local vulnerabilities, and apply all the patches. So a few conclusions and further research. So as I've demonstrated, physical access is no longer a requirement to trigger USB bugs, certainly on Windows, maybe on other operating systems as well. Remote effects has exposed the Windows kernel, and therefore, you know, these kind of kernel level attacks are now available over the network. I need to look at some of the other remoting technologies like Citrix, for example, which may well apply in a similar sense. And the Internet of Things is full of USB possibilities. Basically, I've taken UMAP, and because it's completely host independent, you can test any USB host out there. Anything that's got a USB port on it and a host stack that processes USB devices, you can test using UMAP. So I'm sure there are thousands of USB host stack parsing vulnerabilities out there that you could probably find using UMAP. So please download it, have a play with it, and find some bugs. Thank you very much. Has anyone got any questions? Yep. The question was, can you actually inject code? It depends on where the actual vulnerability is. Now, some of the trigger points within the USB descriptors that get exchanged at the enumeration phase time are very small. However, it depends, it's kind of a case-by-case basis really, because even in some instances where the trigger point is small, there are other descriptors that can be significantly larger. So you could potentially put your payload in a different descriptor that would be available in a different memory buffer at the time of exploitation. But yeah, it is very, very much on a case-by-case basis, depending on which descriptor the bug's in and what OS is parsing it. Any more? Yep. Yeah, that's not something I've looked at. I'm sure in a similar sense, the kind of virtualization of the USB stack maybe contains parsing bugs just like, kind of real USB stack. So yeah, it's certainly another area to look at. Great. Okay, thanks very much.